You give your AI a task, hit enter, and the screen switches to a loading spinner. For the next few minutes, you are essentially staring into a black box. You have no idea what it is actually doing in there. That stretch of waiting usually comes with a specific kind of anxiety. You sit there wondering if the software is diligently crunching your numbers, caught in a glitch, or actively making a mess of your local files. The process happening behind the spinner follows a rigid, mechanical sequence. It runs on the agent loop. This continuous cycle maps out a plan, takes action, checks the result, and repeats until the goal is met. Visualizing this loop lets you read the AI's progress and identify exactly where the work needs your intervention. When your task arrives, the AI does not immediately start flailing at your folders. Its first move is to work out what the job requires and draft a specific written plan. You see this plan before the heavy lifting begins. Correcting a single paragraph of strategy costs almost nothing, whereas letting it build a 20-page document based on a misunderstanding costs you 20 minutes you won't get back. To touch the outside world, the AI uses a strict tool hierarchy. First, connectors, integrations to services like Gmail operating in seconds. Second, a browser extension. Finally, direct computer interaction, physically reading your screen. Each step down this ladder is significantly slower. The execution speed correlates directly to these connections. A task finishes faster when you provide direct software pathways that bypass the slower fallback methods. Eventually, the AI has to execute the actual work. It needs to parse messy spreadsheets, run complex calculations, or write scripts for a chart. This diagram illustrates the sandbox, an isolated virtual machine. Code runs securely inside this thick container, walled off from critical system files. While execution is tightly contained, the output is real. The finished file passes out of the sandbox directly into your actual file system. After that sandbox action finishes, the loop moves to the evaluation phase. The AI pauses to read the actual results of the step it just took. A traditional macro would just blindly play the next keystroke, even if a file was missing or a search came back empty. This software looks at the missing file, recognizes the error, and actively pivots to search somewhere else. This capacity to evaluate results and pivot tactics defines the software as an agent, distinguishing it from a pre-written automation. When you assign a large, complex request, like compiling a brief on 3 different competitor companies at once, the loop scales up. It identifies those 3 companies as independent subtasks and splits them apart, running all 3 research workflows in parallel to save you time. But scaling up brings us to a common trap, trying to figure out if a multi-step task is just taking a long time or if it has genuinely broken down. This graphic shows the difference. A healthy task, even a slow one, shows continuous forward movement through new steps. A stuck task repeats the exact same failing action on a loop or wanders off into irrelevant files you never mentioned. Because every single turn of this loop consumes a fraction of your usage allowance, learning to spot that repeating pattern early allows you to step in and protect your budget. Seeing these internal mechanics changes your daily workflow. Once you know how the engine operates, you naturally begin to write tasks catering to it. You will start naming outcomes more clearly to force a better initial plan. You will connect daily services to keep execution in the fast lane, and you will learn to judge progress by the pattern of actions rather than the clock. Demystifying this process removes the mystery of the loading spinner. It turns a frustrating black box into a predictable, steerable engine for knowledge work. To keep mastering the mechanics behind AI tools, follow us on LinkedIn and Medium. To scale workflows across your team, Spillwave is the partner that maps the implementation from start to finish.
Spillwave helps companies become AI first through practical mentoring, executive and team training, and custom AI solution development. Rick Hightower, co-founder, is a former senior distinguished engineer at a Fortune 100 company where he focused on bringing ML and AI insights into real frontline business applications. Today, Rick and the Spillwave team works with leaders and teams who want to move beyond AI experiments and build real AI capability inside their companies. He helps organizations adopt AI safely, train their people, redesign workflows, and build practical AI systems that create measurable business value. In this video, we learn exactly what happens between your prompt and your finished file, the plan Claude Cowork creates before acting, how it chooses between connectors, browser, and screen interaction, what it means for code to run in a sandbox, and how to tell whether a long-running task is healthy or stuck. Understanding this loop is what turns Coworker from something that sometimes does what you meant into a tool you can aim with confidence. When you give Coworker a task, Claude reads your request and writes a plan, picks the single most precise tool for the next step, runs that step inside an isolated virtual machine on your computer, looks at what came back and decides the next step, splits work into parallel subtasks when that is faster, and repeats until the goal is met. Do this today. Watch the next task you run with the loop in mind. See if you can spot the plan step, the tool selection step, and the adapt step as they happen. Notice which tool Claude reaches for. Look for connector calls, fast, labeled by service name, versus browser activity, slower, shows URLs, versus screen interaction. Practice the stuck or working judgment. When the next task takes longer than expected, ask yourself whether the steps are still advancing through the plan, not whether the clock looks long. Connect at least one service, Gmail, Google Drive, or Slack, to Coworker before your next task. Every connector you add moves work out of the slow lane into the fast one.